In this video, we're going to get a brief introduction to 3D plotting. Our main objective will be to use MATLAB to produce three-dimensional plots using the following built-in functions: EasyPlot 3 and EZSurf, and we'll get also a general introduction to the whole easy approach to plotting functions. And we'll also look at using plot 3, which is the 3D analog to the plot function, and surf, which we can use to plot surfaces. Our general goal is to just get a brief introduction to these functions and plotting in 3 dimensions in MATLAB, which is a very powerful visualization tool to see what functions of 2 or more variables are doing. We want to become comfortable using MATLAB help to learn how to use any plotting function. So by learning the language of the inputs and in general how these functions work, hopefully you can explore other MATLAB functions as you need them in your academic and professional career. So first let's talk about EasyPlot and EasyPlot 3. MATLAB's EasyPlot functions are for creating what we'll call quick and dirty plots of functions to help visualize their behavior. The main goal here is just to get an idea of what does a function look like, and the syntax is very easy. EasyPlot takes 2 inputs. The first input, call that function, that is a defined previously as an anonymous function. And then A and B, this basically gives us xmin and xmax. The EasyPlot function decides the increment and how many data points, etc., and just plots a line. EasyPlot 3 is similar but in 3 dimensions, and in this case the 3D function is defined parametrically. And if you haven't seen that in your math classes, basically what that means is we have the x values are defined, say, as x of t, y values are defined as a function y of t, and z values are defined as a function z of t, and then a and b are t min and t max. So let's look at a couple of examples of how we can use EasyPlot to get a quick look at the behavior of a function. So here's an example of just plotting the function 2 times the sine of x over 3 plus 1. So first we just define this as an anonymous function, and I just want to introduce a term here. When we do that, we'll call this term f as the function handle that we can then use to pass that function along to other functions. So EasyPlot is another function, and the first input f, that is that function handle for the function that we want to plot. And then we have again the domain that we're going to plot it over from 0 to 8 pi in this case. And you'll see for EasyPlot we have an automatic title that function generates, automatic x-axis label. Again, EasyPlot's for a quick and dirty function. So one thing you'll note is there's no option for EasyPlot for a format string like we used with the plot command. You might recall stuff like solid black line for a format string for the plot function. Again, EasyPlot is just for getting a quick look at what is that function doing over a certain domain. EasyPlot 3 is similar. Here's 3 parametric functions that define a helix: x equals sine of t, y equals cosine of t, and z equals t. Together those 3 functions define a helix, and we can get a look at that using the EasyPlot 3 function. And again, we enter the 3 function handles, and those 3 function handles are passed to the EasyPlot function so that it can evaluate these functions for values of t from 0 to 20. So that's, again, tmin and tmax. And that gives us this helix. So that's all we're going to talk about for EasyPlot. See the help. There's some variations on other things you can do with EasyPlot. I would go check MATLAB help, and you should be able to get an idea of what those other options do. The next thing I want to talk about is EZSurf. This is analogous to EasyPlot, but we can use this to look at the behavior of a surface defined by a function of two variables. So if we have a surface Z, where Z describes a surface, and the points on that surface are defined by the function, which is a function of x and y, we can use EZSurf. Now, this is a single function handle, fun Z, and we have a range in x, or an x domain, and a y domain. So note the difference here between EasySurf and EasyPlot3. For EasyPlot3, we have 3 different function handles because our function is defined parametrically in terms of one variable t. We have x of t, y of t, and z of t. That's for EasyPlot3. For EasySurf, now we've got a surface z, which is a function of f of x and y. So a little bit different here in how this is defined. So let's look at an example with EasySurf. So here's EasySurf plotting the function z is equal to the 2 raised to the power of the negative square root of x squared plus y squared. So that's 2 raised to the negative square root of x squared plus y squared. That is what z is equal to. And we use EasySurf. Here's our range. That's our x range. This is our y range. Sorry, that's should use the right math terms. Those are domains that we're plotting over. And this plots this cone. You'll note this kind of looks like a cone. When you get into the figure window with a 3D figure, you can rotate in the figure window to help visualize. And you'll see a button on the top of the figure window that helps you do that. Helps you rotate. So experiment with that as you're working through these examples and working on the homework. So there's the EasySurf. So you'll notice all of these functions, EasySurf, EasyPlot, they work very quickly to plot a function and get an idea of what its graph looks like. But they don't offer a lot of formatting options. They also don't allow us to plot data. They only allow us to plot a function. So let's look at the more general plotting functions in 3 dimensions. So plotting data in 3D, the first option is using the plot3 function. This is similar to EasyPlot3, but now x, y, and z are 3 equal length vectors, not functions. So these are similar. This is analogous to the plot command that we did in 2 dimensions. And we can think of the values of the elements of z corresponding to the same locations in the vectors y and x. So we can use plot3 to plot functions z equals f of x, y, where z defines a curve in 3D space as opposed to a surface. Note, this is different than EasyPlot3. EasyPlot3, we had to have the function defined parametrically, where we had x, y, and z all defined in terms of t. But for plot3, we can use z equals f of x, y, or we can generate x, y, and z parametrically as functions of t. It doesn't matter because x, y, and z are just 3 equal length vectors, and MATLAB does not care how we create them. So really we have a lot of flexibility here. So here's an example of just plotting some data with EasyPlot 3. So here's 3 vectors, x, y, and z, that maybe represent some experimental data. Then using plot 3, you'll note now with plot 3 we can have better format control. But we do have to label our axes manually. We might want a title here, which I didn't put. Those commands are the same as they are with the plot command. So here's a plot where we just plotted some data points with these red pentagrams in a 3-dimensional data set. We can also use plot 3 to plot a curve that's represented by a function. So in this case, we can use that same function again. This is z is equal to 2 to the negative square root of x squared plus y squared. But now we're using plot 3, and it plots this as a curve, not a surface. So this is an important distinction. Here, each value of x and y have one corresponding value of z. So we have this curve that actually looks like the profile of the cone surface that we looked at previously. And we'll look at how we can generate that actually with the surf command. So this is a key difference between plot 3 and surf. Plot 3 is always going to plot a line. If we want a surface, we need to use surf. So let's talk about that. So a surface plot can be used to plot a function, z equals f of x, y, that defines a surface. In this case, now, x, y, and z are not vectors. X, y, and z should be equal sized matrices. So what we're going to have here, for example, is x, 1, 1, and y, 1, 1 correspond to z, 1, 1. For example, x, 3, 5, and y, 3, 5 correspond to z, 3, 5. So we're going to have big matrices of x and y, and there's a corresponding z point to every point in x and y. And let's look at how we can generate this type of data with MATLAB. What we need to do is we need to create an XY grid. We generally think of x and y. So if here's our, if this is our x and this is our y, and let's say here's 0, 0, and this is 0.2, 0.4, 0.6, 0.8, 0.2, 0.4, 0.6, 0.8. We know we can generate a vector that represents these x values using something like x equals 0, 0.2, 0.8. And similarly, since y is the same, y is equal to 0, 0.2, 0.8. But that gives us these the points along the axes here that I'm marking in red. But in order to evaluate z, we also need the interior point. So we need to generate this point. For example, that point would be represented by, so this is 2 in and x and 2 in and y. So this point, we would have x, second row, second column is equal to 0.4, and y, second row, second column is equal to 0.4. Similarly, we might look at this point. That point, to generate that XY grid, that point we might have x. Now I'm using, by convention, this is a MATLAB convention, using capital letters to represent the matrix analogs to these vector axes. So x, this would be the first row of x, and the 1, 2, third column, and that one is equal to 0.2, and y, again, first row, third column of y to get that corresponding point in y, but that corresponding point in y is 0.6. So that gives us that point in space. So we have to generate this spatial grid in the xy plane in order to do the surface plot. And we do that using the mesh grid function. The syntax for that, MATLAB will generate this automatically, these two matrices, x and y, from the vectors as just x, y is equal to mesh grid, lowercase x, lowercase y. So these two are the vectors that basically define these two axes. Here's the x-axis and here's the y-axis. And the mesh grid command outputs these two matrices, big X and big Y, where the elements in those matrices represent all of these points in this XY grid. So let's look at an example to generate that same cone that we generated with EasySurf. So that same cone, again, we can generate X and Y using the linspace. We can generate these two vectors using the linspace command, and then here's the mesh grid command to generate the matrices x and y. We need to do this before we calculate z. And so here we calculate z. Again, z now is a matrix of elements corresponding to, it's the z values corresponding to all of those points, all of the points in the XY grid that we created with the mesh grid command. So now we calculate z, and then we can use the surf command to create that surface plot, and then we can label it. So here we have the same plot. This was the same as the EasySurf example. But in this case, we've generated this from data. So you might ask, well, this seemed a lot harder than using the EasySurf, so why would we use surf? And the answer to that is, again, the EasySurf, just like the EasyPlot and EasyPlot 3, is for quick and dirty plots to see what things are looking like. They don't give you as much control over the appearance of the plot, and they can't be used to also plot data. Say if we had some experimental data that we thought should lie on this surface, we can use that as well. So the surf plot, again, is just a more general option. Here's some other 3D plotting functions that we're not going to talk about in detail. The contour plot plots contour lines of a 3D surface in 2D. So think about if you've ever looked at a topo map, that uses contour lines. A topographic map is an example thinking of contour lines. You can think of this as a topographic map of the function. SurfC generates a surface plot with contours in the XY plane below. And I'm going to let you experiment with that one in the homework. And a mesh plot is very similar to a surface plot, but the surface is not filled with color. Basically, the color variation just happens on the lines. So we have the grid lines only. With all of this, the main idea is to get a broad introduction as to what these different types of plots are, with the goal that you now are becoming familiar with the MATLAB help system and can use that for more information on the specifics of using the options within these plotting functions and figuring out which plotting function to use for a specific application. And that concludes this introduction to 3D plotting.